Right, so we're talking about real numbers. Now, real numbers can be broken down into other types of numbers. Rational numbers, which of course basically any number that can be written as a fraction, I suppose, is the easiest way of saying it. More technically, rational numbers expressed in the form a over b, where a and b are integers. Okay. Irrational numbers, simply something that's not rational. The prefix ir basically means not, I think. I think it comes from Latin or Greek or somewhere, but so anything that's not irrational. But the interesting thing is, irrational numbers, therefore, cannot be written as a fraction, because we've just defined rational numbers to be numbers that can be written as fractions. Now, any irrational number can be expressed as a unique infinite decimal. And the reason why it has to be infinite, because if it stops, then you could write it as a fraction. And as soon as you can write it as a fraction, it's not irrational, it's rational. So it goes on forever and ever and ever. We're going to prove the square root of 2 is irrational, because the other numbers that are irrational, surds are the classic ones. If we don't know the square root of something exactly, then we can't write it as a fraction. Well, how do we prove that? This is a proof by contradiction. So we start off by assuming the opposite of what we want. So I'm going to assume the square root of 2 is actually rational. Now, if it is rational, by our definition, I can write it as a fraction, a over b, where a and b are integers, whole numbers. Okay. So a and b, I've simplified it fully, so a and b have no common factors. Play around with that. So b root 2 is equal to a. 2b squared would be equal to a squared. Now hang on a sec. 2b squared is equal to a squared. That means a squared has a factor of 2. Right. But the thing is, if you've got a square that has a factor of 2, it must have a factor of 4, because it's a square. So all its factors will appear twice to make up the square. Right? Right? Think about, I'm trying to think one which is not just a prime. Okay, 64. 64. It's 8 times 8, obviously. But if we were to break down the factors, we would get 2 to the power of what is 64? How many? 6. So it's to the power of an even number. Because basically what we're saying is 2 cubed times 2 cubed. So all the factors must be repeated. So what I'm getting at is a squared couldn't just be divisible by 2. It has to be divisible by 4. Because all its factors must be, we must be able to write it as perfect squares times perfect squares. So any square that's divisible by 2 is divisible by 4. So it's the same for any number. If you had a square that was divisible by 3, it must be divisible by 9. A square that's divisible by 6 must be divisible by 36. Okay, so we now know a squared is divisible by 4. Now, if that's true, remember we said a squared was 2b squared. Then 2b squared must be equal to 4, there's one of my factors, times k, some other factor. And that factor is going to be a whole number, it's going to be an integer. So b squared is equal to 2k. B squared is equal to 2k. But that means a squared and b squared are both divisible by 2, or both divisible by 4 for that matter. So they've got a common factor. But hang on, my assumption at the start said a and b don't have a common factor. If a and b don't have a common factor, and I've just proved it does have a common factor, my original statement must be false. So if my original statement is false, that was the square root of 2 is rational, then the opposite must be true. Square root of 2 is not rational. The fancy word for that is irrational. So that's what we call a proof by contradiction. You start off with the opposite, and then you go through and you prove something and you end up contradicting yourself. You'll say one thing's true and then you'll say it's false. And they go, hang on, that can't be right. So the only logical conclusion is what I started with was wrong. Anyway, there's only a couple of questions out of that one, but see how I wrote root 3 there? That's similar to one of this. Have a go at coming up with a proof why the square root of 3 is irrational.